So, welcome to week 6. This is more of chapter 13. So last time we talked a little bit about molarity because we were preparing solutions. This time we're going to walk through all these. Again, I'm not really going to go through parts per million, but I wanted to put it up there because they do use it in the medical field, and I know a lot of you are headed that way. So parts per million is a thing, but we are just going to worry about mass percent, mole fraction, which sounds scary because of the word fraction, but it's really not scary. Molarity and molality, which is annoying because there's an R and an L, and other than that, the word is the same. So first we're going to talk about molarity, and then we'll just basically go through a calculation of each of these so that you know how to find all of these ways to express concentration. So the next couple problems, we will deal with essentially the same information and just do different things with it in order to get what we want for our answer. So molarity is moles of solute. Remember, solute is the solid that you're dissolving in there, the one that's the smaller amount. And we are dividing by liters of solution. Solution, remember, is solute plus solvent. So it's like the whole shebang. Molality is the same numerator, so we're still using moles of solute, but on the bottom now we have kilograms of solvent. The reason why that molality even exists is because if you remember back to your gas laws, if you are doing an experiment over a wide temperature range, so say, like for instance, I did some kinetic studies at room temperature, and we went all the way down to like negative 78 Celsius, and so that's a pretty big temperature difference. And when you change your temperature, your volume will change too. So if you are using volume in your calculation of concentration and you are changing temperature, that volume will change, and so your concentration will not be what you think it is at different temperatures. Whereas when you are doing temperature studies, mass doesn't change with temperature. So molality is a good way to express concentration when you are doing a temperature dependent study, which is why it exists. Why it exists with pretty much the same name, that I cannot explain. Okay, let's start solving some problems. Okay, so this exact wording will be, we're going to keep solving this problem for different things, and so there's going to be information in here that we may not need for whatever we're solving for. So we need to choose the right information as we go. Okay, the question is asking us to calculate molarity. Molarity, remember, is moles of solute over liters of solution, which is all the stuff total, solute plus solvent. We have 17.2 grams of ethylene glycol, and that's ethylene glycol. We have 0.5 kilograms of water. So this is our solute. Water is our solvent. The final volume of the solution, so that's everything, is 515 mils. So this is the total. So in order to find molarity, first we need moles of our solute. So our solute is ethylene glycol. We are given the chemical formula, so I'm going to just find moles of solute first, which in our case is ethylene glycol. I'm just going to call it EG. All right, so I'm going to say 17.2 grams. The molar mass of ethylene glycol is, we do 12 times 2 plus 1 times 6 plus 16 times 2, and you get 62 grams per mole. Okay, grams cancel. We end up with 0.277 moles of solute. Cool. All right, to find the molarity, we need moles over liters of solution. So let's look up in our problem. We do have information about our solvent, but I don't need it. So I don't care about my solvent. What I care about is my solution, and I have a volume right here. So if I need liters of solution, in order to get that, I have 515 milliliters. I got to convert that to liters. I know that I have 1,000 milliliters in 1 liter. So when I do that, I get 0.515 liters of solution. Okay, now I just put it together. Molarity equals okay, and we have, with some rounding, molar. That's my molarity. Okay, we didn't need kilograms of water, and we found our molarity. So that's how you do that one. Okay, number 11, same type of problem. This time we're using sucrose. We have a certain amount of water. We have a final volume of solution. We need molarity. Pause, give it a try, see what you get. All right, so here is your solution. No pun intended. Moles of sucrose. The molar mass of sucrose is 342 grams per mole. So you have 0.147 moles of your sucrose, which is the solute, which goes on the numerator. Your what we need on the bottom is liters of solution. Solution is in red. We don't need the solvent, so I crossed it out just because I don't need it. So I don't want it to confuse me, so I'm just going to cross it out. Liters of solution is down here in red. I got to go from milliliters to liters. I just divide by 1,000, and then I solve it down here in green, and I get 0.415 molar, big M, for my unit. All right, so that's molarity. Next, we have a solution, same thing. Here's our ethylene glycol again. Solute. Here's my solvent. And here's my solution. What do I need? I need molality, which is fancy M. All right, so molality is moles of solute over kilograms of solvent. Okay, so now I don't need the solution this time. Who cares? I don't need that information. I do need this now because I need solvent on the bottom. I found the moles of my solute the first time with ethylene glycol. I don't need to do it again. I can just look back and see what I got. So the last time I did moles of ethylene glycol, I'm just going to redo it for this one just to show you again. I did 17.2 grams. My molar mass was 62. And I calculated 0.277 moles. I can still use that. That's the same. It's the same solute. It's the same amount. I'm good. Now I need kilograms of solvent. Well, my solvent is water, and I have kilograms. Life is good. Let's solve. Molality, fancy M. Moles of solute over kilograms of solvent. Okay. You solve it out, you get 0.554 molal, which, remember, this is the same solution we had before. So my molality is different than my molarity because my denominator is different. All right, so you guys need to do the same thing with your sucrose solution, except this time we're finding molality. So you can pause and solve your problem. All right, here it is. I have 50.4 grams of sucrose, which is my solute. I already found the molar mass. I already found the moles of that. So this I had already solved for. Remember that my molar mass was it was 342. So I took my 50.4 divided by 342. I got my moles. That's my numerator. My water, it gives me, it's right here. That's my solvent. I don't need this information, so I'm just going to cross it out so I don't accidentally use it. Here's my denominator, my kilograms of solvent. So now I have my molality. of my sucrose solution. Done. So that is molarity and molality. Same problem. This time we're going to do percent solute by mass. All right, percent by mass. What you want is the mass of your solute over the mass of your solution, so the whole thing. All right, so you want to take the mass of the solute plus the mass of your solvent, add them up, and then we multiply that by 100 to just get it to a percent, and that is my formula. Okay, so I got to look up here and figure out what I have to do. All right, so here's my solute. I need that. Here's my mass. I don't have to convert to moles. I don't have to do anything. There's my numerator. My ethylene glycol I get is 17.2 grams. All right, so I need the mass of my solution. Okay, well I know that my solute's 17.2. I need to add it to the mass of my solvent. So my solvent is water, and I have 0.5 kilograms of it. But I can't add kilograms to grams, so I have to take 0.5 kilograms and convert back to grams. So if I convert back to grams, now I have 500 grams. Okay, so I gotta put that here. So that's my mass of my solvent. So if I add these two together, what do I get? 517.2, obviously. There's my denominator. So if I go back and plug it in, I'm going to take 17.2 grams. I divide by my 517.2, and then I multiply by 100 to get my percent by mass. Baby's not happy. All right, I'm going to finish this quick. And that's 3.33% by mass. Okay, add up your denominator. Make sure you add solute and solvent to get the solution. You cannot use this volume. Cannot use it. Don't use it if you need mass percent. All right, here's this one. Give it a shot. See if you can get the percent by mass. Here it is, solution for 15, mass of the solute, we have it right here. I need the mass of the solution, so I need the solute plus the solvent. Here's my solvent, it's the water, don't use that, I don't need it. I need mass. I cannot use density to convert this volume to mass because it did not give me the density, and this is not pure water. And it doesn't say assume density of water, so I cannot use it. Sometimes people try to convert. Don't. They give it to you. It's right here. All you have to do is change it from kilograms to grams, which I did. So you add those together. There's your denominator. Mass of solute, mass of solution, divide, multiply by 100. Here's your mass percent. Okay. Last one. Mole fraction. Mole fraction is essentially the same thing as a mass percent, except that you are using moles of your solute over total moles, and I don't have to multiply by 100. So there's no unit. It's just the mole fraction. All right. Again, you have the same numbers. I need moles of my solute over total moles of my solution. Okay. It's going to take a little work because I have mass, but it's all good. So I'm going to take 17.2 grams. I got to convert it to moles. I did that already a couple problems ago. So I can just use my 0.277 moles. All right, moles of solution, I have to add up my moles of solute plus solvent, which isn't a problem. I just have to get the moles of my solvent. Here's the mass of my solvent. It's water. So I got to take this 0.5 kilograms, which is 500 grams. I need to find moles. The molar mass of water is 18 grams per mole. So the moles of my water is huge compared to my solute, but that's all right. Okay, now I can find my mole fraction. Moles of solute. Total moles on the bottom. Okay, divide them up, and I get about 0.01. No units, that's it. Convert to moles and then just do the same thing as you did with mass percent. All right, here's our sucrose again. Your turn. Here's the solution. You have moles of solute. We found this before. Here is your water, that's your solvent. So I got to go from grams to moles. I don't need this. I find moles because 18 grams per mole here, that's the molar mass of water. Divide, you get your moles of water, and now I just plug it into my equation. Moles of solute, moles of solution on the bottom. My total moles are on the bottom. And so here's my mole fraction. And there you have it. So that's how you find all of those ways to express your concentration. And given the same information every time, we just do something a little bit different with it.